We already learned the basic probability in the class already, and in this slideshow, I will show the basic principle about the independent and the dependent event, and show you what's the difference between independent and dependent event. So the object, of course, is finding the probability of the independent and dependent event. So start with the definition. The independent event has the definition: the occurrence of one event does not affect the probability of the other. Okay, so the uh, dependent event is the occurrence of one event does affect the probability of the other. So what does this mean? The independent event. So based on the word independent, that means just it's independent. It doesn't affect by the others. So it is what it is. So the never change of these probabilities. Doesn't matter what the others say, the probability doesn't change. So let me give you an example. So if let's see the event A is you go out play basketball. See event B, okay, event A is you go out play basketball in Columbus. Let's see if you live in Columbus. So event B is if today will be raining in China. So does the matter if China is raining or not affect you go out to play basketball in Columbus? I guess that's no. So that means the event A and event B doesn't affect each other. So that means it's independent event. So let's see if your probability you go out play basketball is like 70%. Okay, so let's using a number to figure, probably not, but let's using a number to say like you go out to play basketball is 70%. Okay, but if that's raining in China, does that reduce your probability you go out play basketball? It doesn't. So that's why we call this independent event, because it's independent from the others. The dependent event is on the contrast. So it is affected by the other event. So let's see the event A is the Columbus will have raining or not. Okay, event B is you go out play basketball in Columbus. So does the raining in Columbus affect the probability you go out play basketball? It is, because if that's raining in Columbus today, then you're not going to go outside to play basketball. Probably stay home, play a video game. You hang out with your friend in somewhere inside. You're not going out to play basketball. So that's called a dependent event, because the event you go out play basketball is dependent. The probability will be depend on if that's raining or not. So that's basic definition. I will giving you more example to indicate what's the difference and how to finding the possibilities. So let's go to the example 1. Okay, so it says you have a bag of 10 red, 8 blue, 8 green, and 6 yellow marbles. So you have a total of 10 at 8. At 6, you have a total of 32 marbles. So what are the chance of pulling a red marble? So do you remember we learned in our class for how to finding the possibilities? So the probability of you getting a red marble is how many red marble divided by how many total outcome. So let's figure out how many red marbles. So we see it says 10 red marble. So the 10 divided by the total outcome we already counted. We added 10 and 8 and 8 and 6 is 32. So it's 10 out of 32. So 10 out of 32 we can simplify, because 10 and 32 both have a 2 in common. So you will divide by 2 on both denominator and numerator. So we will have is 5 over 16. 5 over 16. So 5 over 16 is the probability if you randomly draw a marble from the bag that is red. So keep on going. Let's see the part B. So what are the chance of pulling another red marble? So You already take out one, which is red. So they ask you, what is probability you take another one also red? So here is the thing. Like here is the time to you decide that's independent or dependent event. So that's the second time you draw from the back, the probability affected by the first one. Does the probability change? Does the probability of you taking another one is also red is still 5/16? So let's say if you take out one red marble, how many did you put it back? They didn't tell you they put it back, right? So if they didn't tell you, normally on your map test or air test exam, they will tell you you put it back or without put it back. They will tell you. But if they didn't tell you, that means they didn't. That means they didn't. So if they didn't take it back, that means after you're taking out one from the total of the 10 red marble, so how many left? We have a one taking out from 10, so you have a 9 red marble left. So similar thing, so how many total outcome is no longer 32 because you take out one red marble. So now we have a 9 red, a blue, a green, and 6 yellow. So now you have a 31 in total. You have a 31 in total. So this is the typical example for the dependent event, because you're taking out one marble without replacing it. That means the total number of the marble change, also the total number of the red marble change. So this is a typical dependent question. So if you're doing the question of you're taking out the ball marbles, so you might want to think about like the key point is you put it back or not. You replace or not. So let's see the Percy. So what are the chance of pulling 11 red marbles? So here is the case. Here is the case. How many red marble we had? We had a 10 red marble, but they ask you the chance pulling 11 red marble. Is there any possible you get one more? No, this says 10, right? So is that possible you get 11? So there's 0 chances. So the probability is 0 because we have a 10. How can we have a 11 red marble? Of course. So that's the probability is 0. And also, do you remember when we're talking about probability in the class, we have a formula. They ask you PA. Let me write it down. PA and B. So PA means the probability of the event A. PB means the probability of event B. So PA and B just means the probability of both event A and B happening. So let's say if PA is the probability you're getting a red marble, the PB is the probability you're getting another red marble. Let's see, this is PA, this is PB. Okay, so the PA and B means you pick 2 times and both without replacing it. So both time is red. So do you remember we learn in the class when we learn the probability in the class, PA and B equal PA, the probability of the event A, times by PB, times by PB. So the probability of event A, we already have it, which equal 5/16. 5/16. The probability of B, the PB is the probability of the event B is 9/31. They are not the same. Do you remember we just talking about, because you're taking out one red marble but you didn't replace it. So that's why it's a dependent event. That's a dependent event. So that's a typical dependent event question. So the total number of the red marble change and the total number of the marble also change. So that's the first example. So let's see another one. So the example 2, giving a spinner. A spinner. You all know what is spinner. Look on the right side. So this says all are the same size. So why they tell you they all the same size? They tell you they are the same size because they want to tell you the probability of you spin each of the number 1 through 5, 1, 2, 3, 4, 5 are the same chance. So let's see if you have the 5 double of the size than the 1. So then you have the double. Of course, the probability you spin a 5 is 2 times than 1. So that's why every time they want to tell you they have the same size, the marble you drop them back also the same size, because they want to tell you you have the equal chance. If you randomly choose one, each of them are equal chances. Okay, so giving a spinner. So let's see what are the question. So what is the chance you spin a 2? So similar thing we do. How many 2 we have? 1, 2, 3, 4, 5. Total we have a 5. Total outcome is 5. How many 2? We only have a 1, 2. So that's 1 out of 5. So keep on going. Part B. So on the next spin. So what is the chance of spinning a 2 again? So also second time it's time you decide, does this is this an independent event or is this a dependent event? So on the previous question, when we're talking about a marble, a bag of marble, if you take out one without replacing it, so the one of the red marble disappear, right? Because you take it out. So it's 1 less. Also, the total number reduced by 1. But when you look at the spinner, if you spin a 2 the first time, will the 2 will be magically disappeared? I guess that's no. The 2 is still here. So if you spin a 2, no matter how many times you spin a 2, 2 is still over there. So no matter how many times you spin, the probability of you spin a 2 is still the same. How many 2 still? The second time is still 1, 2. How many outcome in total? Still 1, 2, 3, 4, 5. Still a 5. So no matter how many times you spin, it's still 1 out of 5. Similar thing when you flip a coin, it's either head or tail. No matter how many times you flip, it's still like the probability you spin you flip a head is still 1 out of 2. So similar thing for the spinner. No matter how. So this is a typical question about independent event. So each of the spin is independent. So keep on going. So since it doesn't matter what happening on the previous spin, so the event are called independent. Okay, back to the formula, we have PA and B. So the probability PA and B basically in this situation means the probability of the event A and B both happening. In this case, in this example 2, means if what is the probability you spin a spinner 2 times, both of the time is 2. Or in another word, okay, what is the probability if you spin a spinner, that's a 2, and you spin another time, also 2. So you combine these two. So it's probability of A times by probability of B. So PA is 1 out of 5. We already did it. So the PB, because this is the independent event, the PB also a 1 out of 5. The total number of the 2 doesn't change. The total number of outcome also doesn't change. It's still 1 out of 5. So it's 1 over 5 times by 1 over 5 is numerator times numerator. 1 times by 1 equal 1. 5 times by 5 equal 25. So this is the basic understanding about the independent and dependent event. So on the next slide, I will give you more example and I will show you some word problem.